Machine learning and future of AI. What is machine learning? Machine learning is a branch of artificial intelligence, AI, that focuses on the development of algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed to do so. In other words, machine learning algorithms are designed to learn from experience and improve their performance over time. Just like how humans learn from experience, machine learning algorithms learn patterns and relationships in data to make decisions or predictions. Types of machine learning approaches. There are 3 types of machine learning approaches. Supervised learning. In supervised learning, the computer is trained on a dataset that contains input-output pairs. The goal is for the computer to learn a mapping from inputs to outputs so it can make predictions on new, unseen data. Unsupervised learning. In unsupervised learning, the computer is given a dataset without any labels or categories. The goal is for the computer to find patterns or clusters in the data without any guidance. Reinforcement learning. In reinforcement learning, the computer learns by trial and error. It takes actions in an environment and receives feedback in the form of rewards or penalties. Over time, it learns which actions lead to the best outcomes. Applications of machine learning. Machine learning is used in many real-world applications, such as image recognition, identifying objects in images, for example, recognizing cats in pictures. Natural language processing, understanding and generating human language, for example, chatbots, language translation. Recommender systems, suggesting products or content based on past preferences, for example, movie recommendations on streaming platforms. Predictive analytics, making predictions about future events based on historical data, for example, predicting stock prices, weather forecasting. How does machine learning work? Machine learning algorithms learn from data through a process called training. During training, the algorithm adjusts its internal parameters to minimize errors and improve performance. After training, the model can be used to make predictions on new, unseen data by applying the learned patterns and relationships. Neural networks. Neural networks are a type of machine learning model inspired by the structure and function of the human brain. A neural network is composed of interconnected nodes, called neurons, organized into layers. Each neuron receives input signals, performs a computation, and produces an output signal that is transmitted to other neurons. The input layer of a neural network receives input data, which is then processed through one or more hidden layers before producing an output. The connections between neurons are represented by weights, which are adjusted during training to optimize the network's performance. How does a neural network work? The working of a neural network is explained as follows. Input layer. The input layer is where the neural network receives input data. This can be in the form of images, text, numerical values, or any other type of data. Each neuron in the input layer represents a feature or attribute of the input data. For example, in an image classification task, each neuron might represent a pixel value. Hidden layers. Intermediate layers in the neural network are called hidden layers. These layers process the input data through a series of mathematical operations. Each neuron in a hidden layer receives input signals from neurons in the previous layer. It combines these inputs using weights, parameters that the network learns during training, and applies an activation function to produce an output. Output layer. The output layer produces the final output of the neural network. The number of neurons in the output layer depends on the specific task the network is performing. Working of neural networks. Deep learning. Deep learning is a subset of neural networks that involves training models with multiple hidden layers. Deep learning has achieved remarkable success in various AI tasks, such as image recognition, speech recognition, and natural language understanding. Important note: the term deep in deep learning refers to the presence of multiple hidden layers in a neural network. Deep learning. Applications of deep learning. Deep learning has revolutionized many fields and is used in a wide range of applications. Some of them are given below. Image recognition, identifying objects, people, and scenes in images, for example, facial recognition, object detection. Natural language processing, understanding and generating human language, for example, chatbots, language translation. Speech recognition, converting spoken language into text, for example, virtual assistants, speech-to-text applications. Autonomous vehicles, enabling vehicles to perceive and navigate the environment, for example, self-driving cars. Healthcare, assisting in medical diagnosis, disease detection, and drug discovery. Gaming, creating intelligent agents and opponents in video games. Let us explore. Exploratory learning and communication. Encourage students to explore deep learning applications and discuss their potential impact on society and everyday life. Future of AI. AI technology is evolving rapidly, and experts predict that it will continue to advance at a rapid pace in the future. New algorithms, models, and techniques are being developed to improve the capabilities and performance of AI systems. Let us read about some of the potential future impact of AI. Automation and efficiency. AI technology is expected to revolutionize industries by automating repetitive tasks, streamlining processes, and increasing efficiency. In manufacturing, AI-powered robots and systems can optimize production lines, reduce errors, and improve overall productivity. In transportation, autonomous vehicles and AI-driven logistics systems have the potential to enhance safety, reduce traffic congestion, and optimize transportation networks. AI in traffic management. Virtual assistants. Virtual assistants like Siri, Alexa, and Google Assistant will likely become even smarter and more integrated into daily life. They could help with homework, manage schedules, and provide useful information with greater accuracy. AI in gaming. Video games with AI-driven characters and environments could become even more immersive and realistic, offering dynamic experiences tailored to individual players. AI in music industry. AI in creativity. AI might be used to generate art, music, and literature, sparking new forms of creativity and expression. You could explore how AI can enhance your own artistic endeavors. AI in healthcare. AI has the potential to revolutionize healthcare by assisting doctors in diagnosing diseases, analyzing medical images, and developing personalized treatment plans. AI systems can analyze patient data, including symptoms, medical history, and genetic information, to assist healthcare providers in making accurate diagnoses and predicting the likelihood of certain diseases. AI in healthcare. AI in education. AI could play a significant role in personalized learning experiences. AI tutors analyze student performance, adapt to individual learning styles, and recommend study plans tailored to each student's goals. Whether it is mastering math, learning a new language, or understanding complex concepts, AI tutors provide personalized guidance. AI in education.